Hello everyone, welcome to Snippet Nugget. In this video, we are going to discuss about how Hashmap or hash table works. Here we are going to mainly discuss about how the storing of keys and values takes place, what is the load factor, what is hash functions, how conflicts are resolved, and how chaining happens. Different types of time complexities in different situations. These are the things we are going to discuss in this particular video. So stay with me. Let us start. What is hash map? Hash map is a way of storing key and value pairs. This is a data structure which helps us to store key and values. For example, if I have lots of pairs of key and values, K1, K2, sorry, K1, V1, K2, V2, and let us say Kn, Vn. There are n pairs of keys and values, and I want to store them in a data structure such that I can query for any of the pair using any of the key. So the hash map or hash table is a data structure which performs exactly this task, where it stores lots of pairs of key and values, and also it helps us to query for any of the key in that data structure in the most optimized way. Okay, so we are going to discuss now how key and value are stored in memory, what is hash function, what happens in case of conflict, and how chaining is done. Similarly, the time complexity of operations like create a key and value pair, retrieve the key and value pair, and delete a key and value pair. So all these four operations are jointly called as CRUD operation or CRUD. Also, we will understand about what is the worst case time complexity of querying. So let us start and move ahead. So how Hashmap works is so first we need to understand Hashmap is nothing but, if somebody tries to confuse you that Hashmap is not an array or Hashmap is basically a table or something, be clear about the concept that Hashmap is nothing but array of pointers. Sometimes we call each of the element as buckets. So when we say Hashmap is array of pointers, it means that it is an array of a node. Just like we have array of integer, array of characters, array of strings, Hashmap is nothing but array of pointers or array of addresses. Okay. Now let us consider that we are going to store several key value pairs. Let us say one key is A and the value is apple. Another key is B and value is C. Now here the key is A, B, and C. These are the cat and so on. Now if we want to store these pairs in Hashmap, the process goes something like this. We have a hash function. Hash functions are very interesting concepts, which takes always two arguments. The size of the Hashmap array. Array size is 8 and our key is A. So our hash function will give us certain output. Remember that hash function can take any types of input for the key, like key can be character, key can be integer, key can be string, key can be anything basically. So for a particular hash map, the key will be of same data type. It can be anything. In this case, the key is character. In this particular case, the array, let us say initially is 8. So consider that or take this as an example, like it gives us the output, hash function output is, let us say 2. So what will happen is that we will have an array, or we can say buckets, 8 buckets. Okay, 0, 1, 2, 3, 4, 5, 8. Oh, sorry, which is function returns us 2. So what will happen is, first step, the hash function will take a and 8, it will give us 2. And the hash map will go, sorry, in the index number 2, it will go and it will see that what is stored in the index number 2. So initially, everything will be null, right? All the addresses, all the pointers in each of the elements in the array, a node in the heap memory. A node will have 3 parts or 3 data. It can have lots of data, but the most important, which is a. The second is the whole value, which is apple pointer. Okay, the next pointer. So, and the next pointer will be null. Let us say the address of this particular node, which is created in the heap memory. At that time, the address of this particular node is 200. So what will happen is, in the index number 2, 200 with this address. Let us say now we store B for ball. So now again, the hash function will take 2 inputs, B and A, 6. So again, in the heap memory, B, ball, and null pointer will be stored, let us say, in address number 300. So at the index number 300 points to this node. So in this way, we keep on storing the key value pairs. Now here there are 2 concepts to remember. The first is the concept of load factor. Default value of load factor, whenever our hash map is 75% full, we double the size of the array. So in this case, 75% of it is 6. It means that when the 6 elements are filled in this array, and now when we attempt to fill the 7th element here, the size of the array will get 8. It will now be increased to the 16, so 15 buckets. And the hash function has such a property that it will still be pointing to A for 2. When we will point for A and 16, it will still give us A for 2 and B for 6. So this is how the size of the hash table or hash map increases when hash map is about to get filled. Default value of load factor is 0.75. So in hash map, there is a way of internally tracking that how many buckets are full. If the buckets full percentage is crossing the load factor, in that situation, the size of the array gets doubled. Thereby, the load of the buckets are shared, like we have basically now more number of empty buckets. This is the first concept. The second concept is concept of conflict, or basically how we resolve the conflict. So let us say when we are storing K for kite, so K and 8, let us say the size of the array is 8 and it gives us 6. So what will happen? A node for the K will be created where key will be K and value will be kite and the next pointer will be null. Now we know that the address has to be stored in the index number 6. So in the index number 6, we will go and we will see, we find that there is already an address, a valid address, 100 address 300, and we find that there is already a node in this address where B is the key and ball is the value and next is null pointer. Key and value pair is stored at the index number 6. So what we will do? We will take the address of the K for kite, let us say it is 550. And we store 550 in this next pointer. So now this next pointer is nothing but 550. So now if somebody asks me that, okay, whether in our hash map there is K, the key K is present or not. So what I will do, I'll feed the hash function with K as the key and the present size as, let us say, 16, and it will still give me the index number 6. That is a property of the hash map, I'm sorry, hash function, that it always gives the same index number for a particular key, irrespective of the size. Okay, so it will go to the index number 6 and it finds that, okay, I should go to the address 300 for finding whether K for kite is present or not. In the address 300, I have B for ball, but here my next pointer is not null. So I'll go to that address, which is 550. So I go to the 550 address and I find K for kite is present here. So in this way, we can see that the finding of a particular key is present or not happens in a constant time, or we can say that bigger of 1, because finding the output from a hash function is a constant amount of time taking operation. Now you can very well ask that what will happen if there are lots of key and value pairs linked with each other at a particular index number. So obviously the chances of that to be happening is very, very, very low. Why? Let us say our hash table has 10 elements. What is the chance of getting the same index number every time? Let us say the first time, if I get the index number, let us say 5, is 1 by 10. Again, second time getting the index number 10, again getting it 1 by 10. So let us say if I want to get index number 5 by probability, by the chance, every time for the n times, the probability will be 1 divided by 10 to the power n. So you can see that this is, which is very, 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 very rare or very unlikely to happen. If there are 10 elements, falling of all the 10 elements into the same index number is 1 by 10 to the power 10, which is almost like 1 in billion chance. Do you really think it is going to happen? No, right? So the chances are 0 for all the elements to be present in the same chain. That is why we consider it as not happening. And we consider the average time complexity or the normal time complexity as O of 1. So now you can clearly see that what is the time complexity for creating a node. Obviously, the hash function takes constant time, the creation of the node takes constant time, and attaching it to the index number, or let us say the last node of the constant time, will be given the final result as of 1 only. In the same way, retrieving a key from a hash map also gives us constant time operation, and updating a key for its value is also a constant time operation. In the same way, if you want to delete a key, then very nice, this is a linked list. We can delete a node from the linked list in constant time. How we will delete? Let us say we have D for ball, which is pointing to K for kite, which is now pointing to address number 750, which is Z for zebra, and we want to delete K for kite. So I will feed the hash function with K and I get the index number 6. I'll go to the address number 300. I find B for ball there. And I want to delete it. So I'll check what is the next pointer, which is 750 here. So it's a constant time operation, right? So we now see that all the operations CURD, everything is constant time operation. That is why we consider Hashmap as the most efficient data structure for this kind of situation. I hope it is very clear to now. If you like this video, please subscribe to this channel. And if you have still any doubts, please comment here. Thank you for your valuable time. Have a nice day.